In this video, we will be rationalizing the denominator, which is where we take fractions that have radicals in the denominator and we eliminate the radicals from the denominator. If you just have one term in the denominator that has a radical, all we need to do is multiply the fraction by that radical over itself. So in this first example, I'm going to multiply by the square root of 5 over the square root of 5. I do that because in the bottom, when I multiply the square root of 5 by the square root of 5, I get the square root of 25, which is just a regular 5. And so the radical goes away and I have a rational number in the denominator. Since I'm multiplying by the square root of 5 over the square root of 5, I'm really just multiplying by 1, so I'm not changing the value. On the top, I also need to multiply top times top. The square root of y times the square root of 5 would be the square root of 5y. And so my final answer is the square root of 5y over 5. So you're allowed to have radicals in the numerator, the top, but you're not allowed to have radicals in the denominator. And notice I can't cancel those 5's because the one on the top is in the square root, the one on the bottom is not. So that is fully simplified. In this next example, I have a square root of 2 in the bottom. This is the same as the square root of 9x over the square root of 2. If it helps me to write it like that, I can. So I'm going to multiply by the square root of 2 over the square root of 2. This gives me a regular 2 in the bottom because the square root of 4 is 2. And on the top, when I multiply top times top, I get the square root of 18x. I can simplify that. The square root of 18 simplifies to 3 radical 2, so it's going to be 3 radical 2x on the top and a 2 in the bottom. Now, in this next example, we have a binomial in the bottom that has a radical. So we need to multiply by the conjugate of the expression in the denominator over itself. So I'm going to multiply this by 1 plus the square root of 2 over itself, which again is just 1. So a conjugate, remember, is when you have a binomial in the form a plus b, the conjugate is a minus b. You just change the sign in the middle to the opposite. And when we multiply expressions by their conjugates with radicals, the radical should go away, making us have a rational number in the bottom. So I'm going to distribute in the bottom. 1 times 1 gives me 1. 1 times the square root of 2 is the square root of 2. Negative square root of 2 times 1 is negative square root of 2. And negative square root of 2 times positive square root of 2 is negative square root of 4, which is just 2. And notice the the two middle terms cancel out. So I just end up with a nice rational number, 1 minus 2, which equals negative 1. So in the bottom, I'm just going to have a negative 1. Now on the top, I have to distribute as well. So I do 3 times 1, which is 3. 3 times the square root of 2, which is 3 radical 2. Negative radical 10 times 1 is negative square root of 10. And negative square root of 10 times positive square root of 2, since they're both radicals, I multiply them together and I get negative square root of 20. I can simplify the square root of 20. That's 2 square root of 5. So I get 3 plus 3 radical 2 minus radical 10 minus 2 radical 5. And none of those terms can be combined, but since I have a negative 1 in the bottom, I can divide each term by negative 1. So each term becomes the opposite, negative 3 minus 3 radical 2 plus square root of 10 plus 2 square root of 5, and that would be my final answer. Here's one more example for you to try on your own. Pause the video, see if you can do it yourself, and then when you're ready, unpause and check the answer. Okay, go ahead and check your work. How'd you do?